Ever pondered the possibility of time travel? Could we one day traverse the past and future as easily as we navigate the present? This question has enthralled humanity since time immemorial, captivating our collective imagination and permeating our cultural consciousness. From the mystical myths of ancient civilizations to the fantastical narratives of modern science fiction, the concept of time travel has been a constant source of intrigue, mystery, and wonder. It's an idea that transcends boundaries, a universal fascination that unites us in our shared curiosity and desire for understanding. Reflect back to the ancient Greeks, who spun tales of time-warping deities and heroes venturing into the future, or the Hindu epic of the Mahabharata, where King Ravita travels to a heavenly realm only to return to Earth ages later. These stories, while fantastical, reflect a deep-seated human yearning to master time, to break free from its relentless forward march, and explore the uncharted territories of the past and future. Fast forward to the modern era, where time travel has taken center stage in the realm of science fiction. From H.G. Wells' iconic The Time Machine to the interstellar adventures of Doctor Who, our fascination with time travel has only grown, fueled by the limitless potential of scientific and technological advancement. These narratives challenge our understanding of the universe, pushing the boundaries of what we deem possible and inspiring us to question, to dream, and to explore. But here's where things get truly mind-bending. What if this captivating concept is not mere fiction? What if science could make it a reality? As we delve deeper into the realm of physics, into the intricate fabric of space-time, we find ourselves on the cusp of a breakthrough that could forever change our understanding of the universe. So buckle up as we embark on this thrilling journey, venturing beyond the realm of the known into the captivating world of time travel. From the pages of science fiction to the chalkboards of theoretical physicists, the time machine has been a symbol of our collective desire to conquer time. The concept of a time machine, a device capable of transporting a being or an object through time, has been a staple in popular culture. This idea, popularized by H.G. Wells in his seminal novel The Time Machine, has been adapted, reimagined, and expanded upon in countless books, movies, and television shows. From the time-traveling DeLorean in Back to the Future to the TARDIS in Doctor Who, these narratives have sparked our imagination and driven us to ponder the possibility of their existence. But could a time machine exist beyond the realm of fiction? As we venture into the world of theoretical physics, the line between science fiction and science fact begins to blur. Theoretical physicists have proposed several concepts that could potentially allow for time travel. One such concept is the idea of a wormhole. A wormhole, in theory, is a shortcut through the fabric of space-time, potentially connecting distant points in space and different moments in time. Another intriguing concept is the idea of a time loop or closed time-like curve. This is a path through space-time that loops back on itself, allowing for the possibility of returning to a past moment. While these concepts are purely theoretical and have yet to be empirically validated, they provide a fascinating glimpse into the potential mechanisms of time travel. So as we delve deeper into the realm of physics, let's keep our minds open to the tantalizing possibilities that lie ahead. Our journey through time has only just begun. Venturing into the realm of time travel, we inevitably encounter a perplexing labyrinth of paradoxes. By its very nature, time travel seems to defy the very laws of cause and effect, creating situations that defy logic and challenge our understanding of reality. One of the most famous of these is the grandfather paradox. Imagine for a moment that you have a time machine. You decide to travel back in time, and for some inexplicable reason, you end up causing the death of your own grandfather before your parent was born. This would mean you were never born, but if you were never born, how could you have traveled back in time and caused your grandfather's death? This creates a paradox, a loop of cause and effect that cannot be resolved. Another intriguing time travel paradox is the bootstrap paradox. Named after the phrase, pulling oneself up by one's bootstraps, this paradox involves an object or piece of information that has no discernible point of origin. Imagine you receive a blueprint for a time machine from your future self. You build the time machine using this blueprint. Then you travel back in time and give the blueprint to your past self. The question then arises, where did the blueprint originally come from? It appears to have created itself out of nothing, a clear violation of the laws of cause and effect. These paradoxes underscore the complexities and challenges associated with the concept of time travel. They serve as a reminder that venturing into the realm of time travel is not merely about mastering the physics of space-time, but also about navigating a maze of paradoxes and contradictions that challenge our understanding of reality. So let's buckle up as we continue our thrilling journey through the enigmatic world of time travel. And as we grapple with the paradoxes and complexities of time travel, let's take a detour into the realm of literature. The concept of time travel has been a staple of science fiction and fantasy for centuries. One of the earliest and most famous examples is H.G. Wells' The Time Machine. Published in 1895, this seminal work introduced readers to a future world where humanity has evolved into two distinct species, the Eloi and the Morlocks. The time traveler's adventures serve as a critique of Victorian social and economic systems. The ability to move through time presented in this novel sparked the imagination of readers and writers alike, paving the way for countless time travel narratives in the years to come. Fast forward to the 20th century, and we encounter Kurt Vonnegut's Slaughterhouse-Five. This novel, published in 1969, uses time travel as a narrative device to explore the effects of war on the human psyche. Its protagonist, Billy Pilgrim, becomes unstuck in time, experiencing events from different periods of his life in a non-linear fashion. The narrative structure mirrors the fragmented, chaotic nature of memory and trauma. Then there's Stephen King's November 22nd, 63. This thrilling novel follows a high school teacher who discovers a time portal in his local diner and decides to prevent the assassination of President John F. Kennedy. King weaves a complex narrative that explores the potential consequences and ethical dilemmas of altering history. These literary explorations of time travel, while fantastical, offer valuable insights into our collective hopes, fears, and fascinations with the concept of moving through time. They remind us that while time travel may be a scientific conundrum, it is also a powerful narrative tool that can be used to explore complex themes and ideas. So let's continue our journey as we delve deeper into the enigmatic world of time travel, not just through the lens of physics, but also through the rich tapestry of literature. Moving from the pages of literary works to the silver screen, the concept of time travel has been a staple of cinema for decades, allowing filmmakers to explore complex narratives and philosophical questions. One of the most iconic examples is the Back to the Future trilogy. These films, beginning in 1985, follow teenager Marty McFly and eccentric scientist Doc Brown as they traverse time in a modified DeLorean car. The trilogy explores the consequences of altering past events and the domino effect it can have on the present and future. It's a lighthearted and entertaining take on the concept, yet it cleverly highlights the potential pitfalls and paradoxes of time travel. Fast forward to 2014, and we encounter Christopher Nolan's Interstellar. This film, grounded in genuine scientific theories, uses the concept of time dilation as a crucial plot device. It shows how time can move differently for astronauts on a planet near a black hole compared to those on Earth. This results in heartbreaking scenes where years pass for the astronauts in the blink of an eye. Interstellar offers a more scientifically accurate, yet equally captivating, exploration of time travel. Then, there's the mind-bending Primer, released in 2004. This independent film, directed by Shane Carruth, presents a complex and confusing narrative where characters navigate a series of overlapping timelines resulting from their experiments with a homemade time machine. Primer is renowned for its intricate plot and its realistic approach to the logistical and ethical dilemmas of time travel. These cinematic explorations of time travel, while varied in their approach, reflect our ongoing fascination with the concept. They provide a visual and dramatic medium to explore the possibilities and paradoxes associated with moving through time. So let's continue our journey as we delve deeper into the enigmatic world of time travel, not just through the lens of physics and literature, but also through the captivating world of cinema. As we traverse the realms of literature and film and delve into the depths of physical theories, let's pause for a moment and turn our gaze inward, examining the role our minds play in our understanding of time. Welcome to the fascinating world of the psychology of time. The way we perceive time is not always linear or constant. It can be manipulated and distorted by various factors such as age, stress, or even the temperature. For example, have you ever noticed how time seems to fly when you're engrossed in an enjoyable task, but drags painfully slow when you're bored or waiting for something? This is known as time perception, a field of study within psychology that explores how subjective time differs from objective time. Now let's connect this to the concept of time travel. In a way, our minds are the most potent time machines we possess. We constantly travel through time in our thoughts, revisiting past memories, or envisioning future scenarios. This mental time travel, as psychologists call it, is a fundamental aspect of human cognition, allowing us to learn from our past and plan for our future. However, it also comes with its own paradoxes. For instance, the telescoping effect refers to our tendency to perceive recent events as more remote than they are, and distant events as more recent. This mental distortion of time can be likened to the paradoxes we encounter in physical time travel. So as we venture further into the mysteries of time travel, let's not forget the role our minds play. After all, any journey through time, whether it's in a DeLorean, a spaceship, or simply in our thoughts, starts within our own perception. The journey towards understanding time travel begins with a single revolutionary theory, Einstein's theory of relativity. Introduced by Albert Einstein in the early 20th century, the theory of relativity reshaped our understanding of the fundamental principles of physics. It proposed that space and time were interconnected in a four-dimensional fabric known as space-time. This mind-bending concept suggests that objects, including celestial bodies like stars and planets, cause this fabric to curve, creating what we perceive as gravity. Now let's introduce a fascinating implication of this theory, known as time dilation. It's a concept that sounds straight out of a science fiction novel, yet it's grounded in the very real and tested principles of relativity. Time dilation suggests that time can stretch and shrink, moving slower or faster relative to the observer's velocity and gravitational field. Simply put, the faster you move through space, the slower you move through time. This has been empirically validated by comparing atomic clocks on board fast-moving satellites to their stationary counterparts on Earth. The clocks on the satellites moving rapidly relative to the Earth tick slightly slower. Yes, you heard it right, time literally slows down. In this four-dimensional space-time, the path that we follow is not always a straight line. It can curve, twist, and potentially even loop back on itself, opening the door to the tantalizing possibility of time travel. This groundbreaking theory set the stage for further exploration into the mysteries of time. It has sparked a revolution in our understanding, propelling us into a realm where time travel is not just a fanciful dream, but a scientific possibility waiting to be fully understood and perhaps one day even experienced. So, let's continue our journey as we delve deeper into the enigmatic world of time travel. Imagine if there existed a shortcut through the fabric of space-time. This is the concept of a wormhole. Just as a tunnel provides a direct route through a mountain, a wormhole theoretically provides a quick journey across vast distances of space, or even time. The idea of wormholes was first posited by physicist John Archibald Wheeler in 1955, and they've been a topic of scientific intrigue ever since. So, what exactly is a wormhole? In the simplest terms, it's a theoretical passage through space-time, predicted by the theory of general relativity. If they exist, wormholes could connect extremely long distances, such as 1 billion light-years or more, short distances such as a few feet, different universes, and different points in time. The mathematics of wormholes is complex, but the concept can be simplified. Imagine a piece of paper with 2 dots on it. If you wanted to travel from one dot to the other, you'd normally have to cross the surface of the paper. But if you could bend the paper and create a hole through it, connecting the dots, your journey would be much quicker. That's the idea behind a wormhole. However, before you start planning your time-traveling vacation, it's important to note that the existence of wormholes is still theoretical. While the equations of general relativity allow for them, we've yet to find observational evidence to support their existence. And even if they do exist, they may not be stable or large enough for humans to travel through. But let's not lose hope just yet. Scientists are hard at work trying to understand the mysteries of the universe, and every day brings us closer to new discoveries. Wormholes, if they exist and can be harnessed, could potentially revolutionize our understanding of space and time. They might even make time travel possible. Could these cosmic shortcuts be the key to unlocking time travel? The scientific community is still seeking the answer. Now let's delve into the fascinating world of quantum mechanics, where the laws of physics as we know them begin to unravel. Quantum mechanics is a branch of physics that deals with particles at the atomic and subatomic levels. Unlike the predictable, deterministic laws of classical physics, quantum mechanics is inherently probabilistic. This means that at these tiny scales, the exact state of a particle can't be known until it's observed, a principle known as superposition. Imagine a particle that exists in multiple states simultaneously, like Schrödinger's infamous cat that is both alive and dead until observed. This might sound bizarre, but it's one of the core principles of quantum mechanics. Now, what if we apply this concept to time travel? Could we exist in multiple times simultaneously? The mind-bending idea of being in the past, present, and future at once could be a reality in the quantum realm. Now let's explore another fascinating principle of quantum mechanics: entanglement. When two particles become entangled, their states become intertwined, no matter how great the distance between them. If one particle is observed and found to be in a particular state, the other particle instantaneously assumes a corresponding state. This phenomenon, which Einstein famously referred to as spooky action at a distance, could potentially be harnessed for instantaneous travel across vast distances of time and space. As we venture further into the quantum realm, the line between past, present, and future begins to blur, and the concept of linear time starts to break down. Could this be the key to unlocking time travel? While we're still grappling with these questions, one thing is certain: quantum mechanics has fundamentally changed our understanding of reality. So what does this mean for the concept of time travel? The principles of superposition and entanglement challenge our conventional understanding of time as a linear one-way street. Instead, they suggest that time could be just another dimension that we can navigate, just like space. Quantum mechanics has opened up a whole new realm of possibilities for time travel. As we continue to unravel the secrets of the quantum realm, who knows what other mind-bending possibilities we might discover? So, what does the future hold for time travel? Could we see it become a reality in our lifetime? As we stand on the precipice of a new era in scientific discovery, those questions are becoming less fanciful and more a matter of when, not if. Ongoing research continues to peel back the layers of the space-time continuum, with each revelation bringing us one step closer to the once unimaginable: traveling through time. Technological advancements are at the forefront of this groundbreaking exploration. Scientists are tirelessly working on theoretical models and practical applications that could make time travel feasible. Imagine a future where we don't just learn about history, we experience it firsthand, or a world where we can leap into the uncharted territory of the future. It's a tantalizing prospect that is closer to reality than you might think, but with such revolutionary possibilities come profound implications. If we can travel back in time, could we change the past? And if we can, should we? These ethical considerations are as crucial as the scientific breakthroughs themselves. They force us to reflect on our responsibilities as potential time travelers and the potential consequences of our actions. Furthermore, the notion of time travel raises fascinating philosophical questions about the nature of reality and our place within it. If we can move freely through time, what does that mean for our understanding of existence? These are the mysteries we'll continue to unravel as we delve deeper into the enigmatic world of time travel. Whether time travel becomes a reality or remains a captivating concept, one thing is certain: the quest for understanding will continue to propel us into the future.